So we have triangle application theorems. Some of this stuff is going to be pretty self-explanatory. Other stuff is going to be a little bit new, but none of it is terribly difficult. A little bit wordy maybe, but not difficult. So the objective for the lesson is going to be to apply theorems about the interior angles, the exterior angles, and the midlines of triangles. New theorems, yay! Okay, theorem 50. The sum of the measures of the three angles of a triangle is 180. Pretty self-explanatory, you know that, but how do you know that? How do you know that a triangle is always going to add up to 180? Well, let's prove it. We've got triangle ABC, which we're given. We need to prove that the measure of angle A, the measure of angle B, and the measure of angle C equals 180. To do this, draw a parallel line through A. When I say parallel, it is parallel to BC. And we're going to call these angles 2, 3, and 1. All right, now you can look at that and know that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. Now also, we said that these two lines, this one, line A, line BC, are parallel to each other. So because of that and what we know about parallel lines, we can say that angle 2 and angle B are congruent because of alternate interior angles, and also because of alternate interior angles we can say that angle 3 is congruent to angle C, and angle 1 happens to be angle A, not even congruent to, but equal to. So now by substitution we can plug in the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. So that's how you prove it. Okay, this is the definition of an exterior angle. Okay, now this definition applies to any polygon. We are dealing with just triangles, but this is going to help us with our next theorem. So the definition of an exterior angle of a polygon is an angle that is adjacent to and supplementary to an interior angle of the polygon. So as far as how this helps us with our next theorem, the measure of an exterior angle of a triangle is equal to the sum of the measures of the remote interior angles. So here we have our diagram, and we're given the triangle DEF with exterior angle 1 at F, and we need to prove that the measure of angle 1 equals the measure of angle D plus the measure of angle C. Now you're going to basically do what we did in the last example, and we're going to draw a parallel line through D, or a line that's parallel to EF. Now we've got alternate interior angles. Angle 1 and this angle here would be congruent. But also, remember that we've got these two parallel lines, but we've got a couple of other things going on. We've got angle E is congruent to this right here because of alternate interior angles. So we've got these two, so we can say, we'll call that angle 2. We could say that angle E is congruent to angle 2 by alternate interior angles. Okay, and we could say that, we could then say, well, if this big angle here, and let's put a point there, and we'll make that G. And we'll say that angle 1 is congruent to angle GDF because of alternate interior angles. Okay, and you can see that angle GDF is angle 2 plus this angle here, which is angle D. And apparently it's not showing. I must have hit the edge here. All right, and we can substitute in, because instead of calling this GDF, we can just say measure of angle 1, since they're congruent, equals the measure of angle D, which we have stated, and the measure of angle 2, which we said was the same as angle E. So plus the measure of angle E. So that's how that works. Now you know how it works. You're going to be using that quite a bit over this unit. All right, finally, midlines. Okay, goes along with Theorem 52. You haven't really talked about midlines before. So a midline is a segment that joins the midpoints of two sides of a triangle. Okay, Theorem 52 says that this midline is parallel to the third side, and its length is 1/2 the length of the third side. So how do we prove that? Well, we've got our triangle here. Triangle GJK. H is a midpoint and M is a midpoint. Okay, and we need to prove that HM is parallel to JK and that HM is half of JK. How do we do this? We're basically proving the theorem here. Well, we could pick a point P and draw a line that is the same measure as HM. So we could say that MP is congruent to HM when we draw this in. Okay, and now that we've established that, we can then say that GM and MK are congruent because of the definition of a midpoint or division, however you want to look at it. And we also know that GMH and KMP are congruent because of vertical angles, and now we can prove that triangle GMH is congruent to triangle KMP. And what that allows us to do is now we have two congruent triangles, so we can say that angle G is congruent to angle K because of CP/CTC. And we can also say now that GJ is parallel, or not G, GJ is parallel to PK because of alternate interior angles. See, we've got angle G and angle, PKM there. Okay, so now we've established that these two lines are parallel. We can also say that GH is congruent to PK by CP/CTC. And then by that transitive product, we can say that because H is a midpoint, remember, and if this is congruent to this, and so is that. So HJ is congruent to PK. So now we've got these two that are parallel and congruent, which means that HPKJ is a parallelogram. And if HPKJ is a parallelogram, that means that HP and JK are congruent also. And since we said that M was a midpoint because we made these two segments equal, we could say that HM is half the length of JK. Because if PH is congruent to JK and M is the midpoint of PH, then HM is half the length of JK. So that's how that works. So midlines, it's important to remember, it joins two midpoints together, and that line that's created by connecting those 2 points is parallel to the third side and half the length. Okay, so here's a practice problem. We've got PST, which is x plus 3y degrees. Angle P is 45 degrees. Angle R is 2y degrees. And angle PSR is 5x degrees. Now I'll help you set it up, and then I want you to pause it and see if you can figure it out. So what do we know? We know that if we take x plus 3y plus 5x, that they have to equal 180. So you combine your like terms and you get 6x plus 3y equals 180 because these are supplementary. Or if you want to call them a more technical term for this particular unit would be that this is an exterior angle to this. Okay, and then we could say that, now you could do this a couple different ways. You could either say that, well, let's do the more obvious one first. 5x plus 2y plus 45 equals 180. Okay, subtract your 45 from both sides, and you get 5x plus 2y equals 135. Now you have a system of equations. So you want to get rid of either your x or your y, because we have 6x plus 3y equals 180, and 5x plus 2y equals 135, and your x's and your y's have to be the same for both. So let's get rid of our y's since that's easier. 3 times 2 is 6, so I need to multiply 3 times 2, 2 times 3. Let's just make the top one negative. Alright, so that's going to give us negative 12x minus 6x equals negative 360. And then multiply the bottom, so we get 15x plus 6, this should be y, plus 6y equals, it looks like it's going to be 405. Which is going to get, these will cancel out, and it'll give you 3x equals 45. So x equals 15. And then you could plug that into either one and figure out what y is. So let's plug it into this one here. 5 times 15 plus 2y equals 135. 5 times 15 is 75. Subtract 75 from both sides, and you get 2y equals 60, so y equals 30. And it wants you to find the measure of PST, so we need that 15 plus 3 times 30. 3 times 30 is 90, plus 15 is 105, so this would be your answer. Okay, now like I said, that's one way to do it. The other way, you would have done this first step the same first. I'm going to erase all the ink on the slide here for a second, so if you need to copy it down, pause it. The other thing is, we still have that, PST is x plus 3y plus PSR, which is 5x equals 180. So you have 6x plus 3y equals 180. And you're essentially going to be doing the same thing, because then you could say that, because remember, this is an exterior angle, and it has to add up to these two combined. So you could also say that PST, which is again x plus 3y, equals at 45 plus r, which is 2y. And then you have to combine like terms, so subtract 2y from both sides, and you get x plus y equals 45. So it's an extra step there, but it definitely makes, because you still have a system that you still have to solve for, but it makes it a little bit easier, because now I only have to multiply the bottom by negative 3, which would give me negative 3x minus 3y equals negative 135, which would be 3x equals 45, and x again would equal 15. So you can do it whichever way you want. Doesn't matter to me as long as you come up with the right answer. All right, hopefully you are watching this over the weekend and not on Tuesday, so that you're ready for class. If not, then you got 2 videos to watch for tonight. Okay? Have a good one, and I look forward to seeing you guys tomorrow for the beginning of a new semester.